Welcome back to the lecture series in cell culture technology. So, we have finished 4 weeks, halfway through the course, and there are quite a lot we have discussed and shared regarding how to grow the cells outside the system. So, if you recollect in the last class where we concluded, we talked about a very specific example where we talked about how the rods and cone cells or the rod and cone neuron or the photoreceptors of the retina preferentially attach to a concanavaline substrate as compared to a commonly known substrate called polydilysine, where most of the interactions are electrostatic interactions, because polydilysine having a positive charge interacts with negatively charged moieties on the cell surface, and by virtue of which the attachment happens. On the contrary, when we talked about the concanavalin, so what we appreciated about it is concanavalin is a carbohydrate binding protein, and if you coat the substrate with a carbohydrate binding protein with an assumption that the cells what you are isolating are having a lot of carbohydrate moieties decorated on its surface, then automatically the cell will get trapped or will get attachment points with concanavalin, right. So, this is where we kind of closed on the last week lectures. So, today before we proceed further, since we are halfway through, we will just take a stock of what all we have covered and how we are going to proceed further. So, let me tell you one aspect, as I told you in the beginning. Like whenever you wanted to offer a course like this is a question always comes, this is a practical course. How you can teach a course like that in the classroom? So, my answer to this is, yes, indeed it is a practical course, but there are aspects, because before you do a practical, a lot of things goes in the brain and jot down on the table. And if one systematically knows the power of a technique, then one really can go back to the bench or go back to the lab as a much more well equipped and a wise individual to design experiments. So, today we will take a stock of the situation, and from there we will slowly diverge or diverse out, and we will travel at different dimensions for the rest of the course, which we have another 20 odd lectures ahead of us. We will see what all different things what we can think which are going to make a difference. Okay. So, we are into week 5 and today is lecture 1. So, W5 L1. So, whenever we talked about a cell, so this is say for example, a cell, the nucleus and the organelle. So, we talk about first is a substrate where the cell will adhere, and we have extensively talked last week about it. Substrate for cell attachment. Then we talk about the medium. supporting cell growth. Okay. Of course, since I am mentioning it, so this is the cell, and cell could be of two sources. It could directly come from an animal, which we call as primary cell, directly from animal, whereas you have cell line which are derived from animal and subcultured. Derived from animal, and here animal I even mean human being too. Okay, derived from animal and subcultured. They are almost like generations after generations you are growing them, unlimited, or you cannot call it unlimited. Cell cycle. Okay. Okay. Right. So, there is one more thing, very critical here, though it is part of this whole ballgame, how to maintain the gaseous exchange, which is part of actually the medium, how you are doing it, and pH balance. So, these are the key aspects of what we dealt in cell culture whenever we talk about it. Now, part of it, substrate, we have talked. If you remember, this we have talked about different kind of synthetic and biological origin substrate. Synthetic and biological origin. And we have this whole detailed list what we have already worked out. But from this substrate concept starts the concept of a newer concept. So, this is our stock taking, that this is all what we have done as of now. So, what we will do? So, we have talked about what we have done as of now. From there we will move on to what all we have to do, which are derivatization of these fundamental concepts which we have already discussed, or some of the concepts which we are about to discuss. Okay. So, okay. So, in terms of the substrate, the next level of advancement where several people in the world are working for last 2 to 3 decades, and the field is really taking a different dimension, is called substrate engineering. Okay. So, this is the next level advancement what we are going to deal. So, we talked about substrate, and now we will talk about engineering substrate. And what does that mean? An engineering substrate when we talk about, we'll talk about engineering substrate in 2-dimension, engineering substrate in 3-dimension. We will come to this. There is this next aspect. If we have talked about substrate, there is next level of advancement what we will be dealing with is out here. Of course, we haven't still talked about medium development. We will be talking about medium development. But what is critical about medium development is defined medium. Sometimes people call it also, or very close to. I won't say that this is the exact meaning, but very close to something we called as serum free medium. And here also there are a couple of questions which comes is why and how. In terms of the medium, we will have to deal with this whole thing. We still haven't really started the concept of medium. Now, exactly in the same way, when we ask this question how, why and how here, the same thing holds true when we have to talk about engineering substrate or engineered substrate, whichever way you love to put it. Engineered substrate, the question is still the same, why and how. Okay. Now, in terms of, there is a third component if you look at it. You see this, we curved out a niche out here, gaseous exchange and pH balance. Okay. Let us curve that niche neatly. Now, when we talk about the gaseous exchange, you have to understand the gaseous exchange is directly linked to pH, and that comes as modes of buffering, which is directly linked to this medium development concept. They are all linked here. Okay. Modes of buffering, and in that line come dependence to CO2 tank, but CO2 tank is used using sodium bicarbonate buffering, Na2CO3. We will talk about this detail, but just keep a track on it, or Na2CO3 free system. And why these are significant? These are significant because as we are moving towards more of engineered systems, it is very essential that we miniaturize the stuff, growing cells on a chip, growing cells on very small substrate, we miniaturize it. And if we have to miniaturize it, we may prefer to have either CO2 independent systems to grow, where you do not have to have a bulky cylinder along with it and a huge incubator, or we miniaturize the whole setup. So, this is again very neatly, if we have to say why and how. So, I just put a word here, lab on a chip, LOC. That is where most of these modern techniques are going. Just a note here in case you forget, lab on a chip, the name of the journal too. So, for that concept, we have to really think about some of these aspects which otherwise is kind of overlooked. Now, next thing where we will not deal like as one cluster, rather we will be touching in and out about it, is cell plating rules, and which varies to cell type to cell type. So, these are the aspects what we are going to deal with in coming sessions of 20 lectures, what we will be dealing out here in this course. Having said this, I designed a different module for this, how to approach this, because otherwise if you look at it, these are fairly drab things, like I say a medium is like this, you add that, and like, which does not make sense, because the question comes when we talk about medium or we talk about engineered substrate, we have to talk about the first, the concept of why and how for engineered substrate, cell plating rules, how, again how and why, similarly how and why in terms of the buffering. But before I get into the individual component in terms of whether it is engineered substrate, whether it is a medium development or a defined medium, or whether it is a lab on a chip, I want to introduce the concept of defined system. This is the emerging concept of all the different cell culture rules or cell culture techniques we are working, which includes, in terms of the system, what we meant is, we said defined. When we talked about defined, we mostly meant chemically, physically, surface property, uniform, and repeatable. So, it is more or less like product development. Okay. And in terms of the system, we talk about, whenever we talk about such defined system, we talked about medium. It should be very well defined, and it should be defined in terms of chemically, its physical properties. Okay. Then we have substrate. Again same way, chemically, physically, and surface properties. Okay. So, you have medium, you have substrate, fine, and then you have these rules: source of tissue, source, uniformity of tissue. What does that mean? Say for example, I am obtaining tissue from an animal of a certain age, that should be fixed. Like if I change, then I have to really mention that this is the change I made. Age, isolation rule, how you are isolating the tissue, especially this holds true for when we talk about primary culture where the variations comes the maximum. Isolation rules. Not only that, how one is processing the tissue. So, these points have to be taken very, very seriously while we are talking about a design or a defined system. So, now this week onward, whatever we will be talking about, we will be talking about a defined system and the need for such defined system. So, our next lecture, what we will be talking about is again the same, why and how. Okay. So, we will talk about why we needed a defined system and how we can create a defined system. Again, the why and the how of this ball game will start. So, what I will do, I will close in here because I do not want to start the defined system just now. In the next class, we will talk about what led to the development of defined system and how we can achieve a defined system. Okay. So, thank you for your patience listening. Next lecture we will resume from here, define system, define substrate, define medium, define techniques of cell culture and their processing. Thank you.